Go? All right. Great. Let's start. Welcome, everybody. Thanks for joining this amazing workshop. So the point of this workshop, let me go to the actual opening slide, is really how you will make an exceptional documentation for your code. And by your code, I mean, if you have seen the description of the workshop, you're supposed to be bringing some sort of code base that you will be working on. Half of the workshop time is allocated on you documenting some actual piece of code that either you own or you use or you like. If you don't have such a piece of code, you can spend the first exercise session finding such a piece of code that you like. But even if you have no piece of code, don't worry, because all the principles that you will learn today, I believe, will be very useful for you. The workshop has some slides that are online. If you go to the pre-talk center of the workshop, you can download the slides. You will be needing the slides to perform the exercises because you will need to refer to the information in the slides. If during the workshop you have any conceptual question, just ask me, raise your hand. And of course, during the exercises, if you have technical questions, myself and also Morten and Frederick at the end over there, we will be just walking around and helping everyone that has any technical questions during the exercises, right? So without further ado, let's start. I like to have a funny approach in everything in life. And when I saw this meme, I kind of fell in love with it, so it's fantastic. So you can make things work without documentation, but definitely documentation makes it better. So let's start with formally approaching and really trying to figure out why should you bother with documentation. And the truth of the matter is because you want people to use your code, right? But of course, if people can't figure out how to install your code, how to use it, then they won't use it. Hopefully, this should sound obvious to everyone because it is very obvious. And the other point is that if you want to learn the software without docs by diving into the source code, well, unfortunately, this is tremendously inefficient, if at all possible. And I have here this very nice quote that says there is a vanishingly small number of people that will source dive to learn any source code, compared to the number of people that would just use it if it's properly documented, right? So the third aspect, or the third reason, because if you have good documentation, similarly to you having good code, this will motivate contributors. And you can only get contributors after already having a user for your code, which happens only after having a documentation. So you should bother with documentation because it is the most important part if you want your software to have greater than one user count. Right. So here's another funny slide. You get a tech job, you ask for the documentation. There is no documentation, just look at the code, no comments in the code, variable names are 3-letter long acronyms. So I've worked for 3 years in such a place. So for me, this sounds very familiar. So let's try to make a better world with this workshop. Right, so here's the outline. Let's say the first component or the first half of this workshop is really about principles of good documentation. And this part is really Julia agnostic. Everything that you will learn will apply to any programming language or environment that you use. And the second part, let's say, is really how you would actively build the documentation for your software using well-established tools like Documenter.jl and Literate.jl. Of course, this part of the workshop is really Julia specific, all right? So as I said, at any point, we can stop and discuss questions you might have. But let's set some expectations right, because in my experience, writing a good documentation is about 6 months full-time job. And this workshop is approximately 3 hours. So of course, there is no way you will walk out of here having an exceptional documentation, even though that's exactly what was advertised. So I'm sorry about that. It was clickbait. The actual goal here is that you first really understand or have a solid understanding of what makes a good documentation. Have a solid foundation of what you need to do to apply these concepts to your own code base, and have a solid grasp on the technical skills required to make this a reality, right? Very good. So all of this was bookkeeping, and now we go to the formal knowledge part of this workshop, so to speak. So to write a good documentation, we first need to understand what is its purpose, and its purpose is multifaceted, because on one hand, documentation is really to teach a new user how to use this software, But of course, it is also a reference for existing users on where to find the thing they need. Now, something that many people might not know is that the documentation defines the public API. API simply means how you use the software, right? This means that the documentation defines what is a bug or not the source code, which might be counterintuitive, because remember, you cannot remember this because the slides come from a much broader workshop on writing good code, and there we discussed that you can only document the intended behavior of a software, not the actual. What this means is that as the software increases in complexity, you cannot deterministically, let's say, figure out what it will do without running it. So that's why you document what you hope it does or what you intend it to do. Sometimes there are bugs and therefore it doesn't do what you intended to do. But anyway, the documentation defines what is a bug or not. Right, so with this in mind, what is a good documentation? A good documentation will make the user understand what this software is about, get an immediate overview of the features of this software, find the information where they expect it to be, and process this information fast and understand it quickly. And also, importantly, have no ambiguity after reading the documentation. So if your user spends time looking at your docs, which is already a rare thing, they really should know what they need to know after reading the docs. Right. So how do we approach creating a documentation for our software so that it is very good? The framework I like and what we will follow in this workshop is what I call several levels of depth of exposition. This means that the documentation is structured in such a way that you go down in depth or in specificity of your documentation. So the highest level in this depth is the summary of what the software does. Just a simple summary, nothing else. Now we go down we go down in terms of specificity. We go down in depth. So the next level is the high level, which is an overarching tutorial on the core of the software as a whole. Then we have an intermediate level, which is composed of examples. So examples showcase end-to-end usage of a specific or an advanced functionality of the software. Now, both the examples and the tutorial, I classify them approximately the same. They have to be run and not written. I will explain what this means later, but I want you to try and really remember this phrase, examples must be run, not written. Keep this in the back of your mind. We go down in depth and we have the low level, which is internals of the software, if you want to document them, or explanations of how parts of the software work. Then we have the lowest level, which is simply the public API, which is where you declare how this software is supposed to be used. The public API is just the documentation strings of your functions and types. Now, the order of specificity, though, is not the order that you should approach the documentation, in my opinion, because when it comes to the priority you should give to its aspects, they go differently. In my opinion, the highest priority is, of course, a summary of the software so that someone can know whether they have to use it or not at all. Then the second level of priority is the lowest level in depth, which is the public API. If you have the public API, you practically already have a documentation, at least according to some. Then priority 3 is the overarching tutorial, and then we have the examples, and finally the internals. So this is what we will learn in this workshop. There is an alternative framework to this, or sorry, we will only learn the first 3 levels of priority. We don't have time for everything, right? There is an alternative to this depth of exposition that is called the ataxis, which is very similar in spirit. The reason I prefer the depth of exposition is because with the ataxis framework, there is no order of importance. So you have a finite time and you need to prioritize what you will write. And at least in this system, that's not clear. And also because in my experience, there is no difference between tutorials and how-to guides. I remain still unconvinced about this. Right, so into the very first thing we have to write about our software, and here comes we are very close to the first exercise session, so to speak. That is the software summary. Now the software summary should be your README, because you want the summary to be at the place someone is most likely to see first. And this just so happens to be the README of your software, at least if you host it on GitHub or GitLab or many other places. So the README of your software is just a simple text file that should summarize your software. And at least in my opinion, this is what composes a good summary. these 6 bullet points. So this is only a couple of paragraphs long, and it has first some sentences of what the software does, what are the major features of the software, what makes it unique, how does it compare to alternatives, and then links to many other things like where is the documentation, how to cite the software, who are the authors, what are related software. Let's have a couple of examples here. Let's see a couple of examples, sorry. Oh, that's interesting. Right, very good. It worked. Right, so I have one README file that personally I think is pretty good. It is about a software that I also maintain, so I'm completely unbiased on this, right? So the README says agents.jl, it's about the software called agents.jl. It says it's a pure Julia framework for agent-based modeling. Agent-based modeling is a computational simulation methodology where something happens. These are the major features of the software that you don't have to know because you may not care about the software, but it is in a simple and nice enumerated list. And then it says, okay, more information can be found in the docs online. I actually skipped this component over here that are badges that also provide links to other regions of the documentation or the test suite or everything else. And then it closes with a citation. This is it, guys. It's really something very simple, but yet you'd be surprised how important this is because you want someone to know at a glance whether they should invest time at your software or not. So this makes a good experience. Let's see another example I have in the slides from Online Stats, which I also think it's a great README file. It starts with a description of what the software is, which provides online algorithms for statistics. It provides then a bullet point list of the key features of the software. It has some nice animation of the usage of the software. Similar badges that provide links to the documentation or how to cite or other information. And of course, links to the documentation. Now, one thing that this README has that the previous one didn't was a simple code snippet that describes how this software works. And then there are other type of details. Now, personally, that's my own personal opinion. I'm not a fan of having any code whatsoever in the README for maintainability reasons that I will explain later on. But it's up to you whether you want to explain to include some. Now, tip and trick, throughout the documentation, I will have this TNT here, which means tip and trick. If your code base is a formal Julia package, Julia will automatically make the README file the documentation string of your module. So let's see this in action. For example, here, this is the agents.jl README file. Now, because agents is a Julia package, it defines a module that is called agents just by itself. Here, I explicitly show you how this is done. There is a way, don't worry if you don't understand the code, we will show this later in detail. But in essence, what this does is that if you go into the help mode of Julia and press question mark and then agents, this will simply print out the README file. And Julia does this automatically for you. You don't have to do this explicitly like I do it here. So this is another important reason why the summary of your software should just be the README, so that if someone is using your package, they can question mark it and then get the README. Right, so README is written in Markdown syntax. Is anyone in the room that is not familiar with Markdown syntax? Then please raise your hand. Don't be ashamed, it's totally fine to not be familiar. If you're not familiar, raise your hand. So you're all familiar with Markdown. Okay, then I can skip this slide, right? So now we're going to the first exercise. So this entire workshop is composed of such iterations. I speak for 10 minutes or so, then you have 10 minutes to actually do what I just said, which is now that you write a README for your code base. Let's start by taking 5 minutes or so, and then in the duration of this 5 minutes, we'll see how it goes, and we can extend it to 10 minutes. Remember, 5 minutes is probably not enough to write a perfect README, but of course, the goal here is that you won't have time to write perfect documentation. It's just so that you get started at each aspect that makes a good documentation. So for now, focus on writing a draft of the README of your software or your code base, and I will leave the slides on this slide where it's the key points that of what makes a good README, in my opinion. All right, let's go. And technical questions, you just raise your hand and someone will help you, I promise. Right, so let's start with 5 minutes and maybe 10 minutes later. All right, Yeah, that's true, right? You only learned this when I was creating controls. Yeah. Yes. Is this the review? Right. So if I were you, what I would do is I would just make the readme be just a paragraph from your opening in the documentation and the bullet point list of the features. That should be enough. The readme really should only be a couple of paragraphs at most. Yeah, so I would add a bit more detail here. I also find it always good if you tell what is the scientific field. For example, online stats that I presented says that it is online algorithm, but I actually don't know what it is. So I think it's always good to explain what is the scientific context of your software, because I didn't know what online stats actually means, and then I went to Wikipedia and learned this, but they could have 1 or 2 sentences. This is the only exercise that you can actually do in the time. Great. Well, you might be called to present the end of the course. You really have to give a good first impression for people. So we're doing interactive sessions for the goals. I did read the but I missed the first. Great. So I hope everyone has done a very good job. If we have time at the end of the workshop, you can actually present what you have achieved today. I would recommend that we pause the README for now, because the next sections are much harder. I hope you have drafted a key outline. This is really the 4 major points you want. I think links is the easy part. Right, so the next part is by far the most important part of the workshop, in my opinion. So you really should spend time on the exercise with laptops open for this part. And it's documentation strings. So now we go down to the very bottom of this depth of exposition framework. Documentation strings are just, also called doc strings, are just descriptions of what a function does and how it can be used. Now, the documentation strings by themselves form the basis of a software documentation. In Julia, a documentation string in your source code is the topmost string above a function's source code. I will show you an example in a moment, don't worry. A documentation string is just a standard string within the Julia, your Julia script or your Julia file that utilizes Markdown syntax that you all perfectly know, which is perfect. Now, documentation strings are written in human languages, just like comments are, but they are not comments. They are superior to comments and should be preferable when possible. Why are doc strings superior to comments? Because they are accessible from the language interactively, first reason. So if you see here my Julia console, if I type question mark, I go into this help mode. Now, if I type the name of a function, let's say find all, what this actually will tell me or will show me is the documentation string of the function. That's why documentation strings are superior to comments, because you cannot just get the comments in the source code of the function this way. The second reason that they are superior to comments is because you can interlace them into your build documentation, as we will see in the later sections of this tutorial. Right. Now, at least in my opinion, the public API, so a public declaration of how this software is to be used, should be defined entirely on the documentation strings of the exported names of the functions and types of your software. There should be a necessity for nothing else, or README or tutorial or anything, for the declaration of the API. A tip and trick for you guys that I really follow, and it is boosting my productivity, is that when I want to write a new function, I first write its documentation string. So I first make a declaration for myself of what I want this function to do, and then I write the source code of the function so that it satisfies this documentation string. In my opinion, this makes for a more productive workflow. Right, so how do you write these documentation strings? Let's see a couple of examples that, once again, I personally believe are good. I have written them, so I am completely unbiased. So this is the documentation string for a Julia type. It's called approximate entropy. This is how you would see this in the documentation that you also will build. The first thing this has is a call signature. This is how will you call this thing? How will you create this type? Then it has this X that is an optional argument because it is in brackets. Then there is the semicolon, which means keywords. There is one keyword here that has an explicit value, and then it says it has more keywords that you will find below. The documentation string has 1 or 2 sentences that simply say what this thing is. This thing is an estimator for the approximate entropy, literature citation here, complexity measure. Used with complexity. Complexity is a function of this software. The keyword R is mandatory if the input X is not provided. Then there is a subsection of the documentation string that is listing all the keyword arguments, and it's also listing their default value. In my opinion, this is the best way to do this. Keyword argument in code syntax, default value, and then a description of the keyword. And then there is another subsection in the documentation string that is a scientific description of what this thing actually is. That you don't have to read. It is a scientific description, so you only care about it if you care about the software. Right. Now let's see how this actually looks like when you write this documentation string. So this is how you will write this in your actual Julia code. As you can see, is a string file. This is a string above the definition of this type or function. And inside it, what you will see is that there is a markdown syntax, and everything that we saw compiled here into HTML actually was just markdown syntax where we wrote it. So documentation strings are just markdown. And you see, This is indented 4 times, so it is code block. This is in backticks, so it is rendered as code. This is a subsection header, etc., etc. So this is what I mean by documentation strings are just markdown. Let's see another example over here that I think is also a good documentation string. And as you can imagine, I wrote it. Right. So now this is a documentation of a function that also satisfies multiple dispatch. So the first entry in this docstring is again the call signature. So how would you use this function in code? It has the name of the function, the first input argument, second input argument optional, third input argument with a declaration, and also the return value or the return type. It says move an agent to the given position or to a random position if the argument pos is not given. And then some more information. Now there is this horizontal line that I hope you can see. I don't know. There is a horizontal line. Then there is another documentation string, because now this documents a multiple dispatch variant of this function, where it dispatches if the second argument is now this ABM type and the third argument is a real number. And then it describes what this second thing does. And if we go to the code, you will see that there is 2 documentation strings in code, of course. One function has 1 documentation string, and then there is the multiple dispatch declaration, and the other function, the other function has the other documentation string where there is the other multiple dispatch declaration. And when we compile the documentation, you don't have to worry about this. Everything is done automatically for you by the amazing software that we will present. Right. So, given the examples we have seen, how would you, yes?
Do you recommend writing a docstring for each version of multiple dispatch definition?
You have to be the judge of that. You should write it for each versions that are sufficiently different. But depending on your code complexity, you might have multiple dispatch variants that the user does not care. So documentation string is what the user reads, right? So act accordingly. There is no universal rule. Yes, please.
I saw that for the abstract type in your function, you call it right there. Like you don't say it's an abstract agent.
Ah, yeah, for yes. So here I don't declare the type. No.
Sometimes struggling in how you types because
when you're naming a variable, it is possible that the name itself conveys the type. In my example, I'm fortunate enough that this is very obvious. It's called agent, so it has to be an abstract agent, right? What else? So here it is obvious. If it's not obvious, always declare the type. This is also why what we will say now. So how to write good docstrings? This is the slide of the workshop. This is the most important slide of this workshop. Please pay attention, right? So the very first thing, absolutely, always a clear call signature. Call signature is simply how you will use this function. Once again, this is the call signature. This is in code syntax, right? Not in natural language or anything. Then there is a brief summary of what the function or type does. What are the inputs and outputs? And here you have to say the types of the inputs and outputs if they are not obvious from the context. Cross references to related functions if sensible. If you remember in the first docstring I showed you, there was this cross reference to a function called complexity. Then keyword, a subsection that lists the keyword arguments and their default values. A subsection that has a detailed description of what this function does. I strongly recommend this if you are doing any scientific software development. Citations to the papers. And lastly, and optionally, example code within the function itself. This is something I personally do not do because I like my runnable code to be a runnable example run by Documenter.jl. Yes, please.
So for the first one,
Personally, I'm a huge fan of writing my own stuff. So therefore, I don't have much experience with this automatic generation. I prefer to write my own stuff because the first sub-bullet point, as you see here, is that, at least in my opinion, the call signature really should have the most important things, right? A function may have many input arguments and many keyword arguments that you could just write args ... in your own version, but maybe the automatic will list everything. So I have limited experience. Personally, I like to write on my own. It gives me nice traditional control, so to speak. Right. So extra colorful slide because it's extra important slide. Okay. This is the slide you will be looking at when you go to the exercises. Now, tip and trick. When you write doc strings or documentation or really anything, be clear what you are referring to. This is also a concept known as pick one word per concept. And this means that if you're referring to the same thing, that you should use exactly the same word, exactly the same. And this is good advice for all forms of technical writing, because this establishes an unambiguous connection between the word that you use, typically English, and the thing that you refer to, which is typically code. So to give you an example, if you use fetch, retrieve, get, obtain arbitrarily in your documentation to mention the same concept, don't. Pick one word, just pick only fetch or retrieve and use that throughout. Sketch, diagram, concept, idea. Similar words, just pick one. And what I write here, I really like, don't optimize word variety, optimize word clarity, because you're unfortunately not writing poetry. Similarly, if you're referring to an object that exists in code, for example, an input argument to a function, you should always use backticks to convey that this object exists in code, because when the documentation is compiled, this is presented as code syntax. So this is code rendered. Again, in the description, sorry, in the here you see that this R is written in a monotype font and has a nice dark purple background. This is because in the documentation string, I have it in backticks. All right. So be clear to what you're referring to. Very important. Now, final slide before we go into the exercises. I'm very glad you all know Markdown syntax. I will now present some enhancements to the Markdown syntax that is provided by the documentation packages that we will use. At the moment, these enhancements won't do anything, but once we compile the documentation at the end of the tutorial, they will do wonders for us. So the first enhancement is that you write some function name that you export in your documentation, and you enclose it in backticks and then in square brackets. This creates a hyperlink in Markdown, but the reference to the hyperlink is just a decorator that says @ref and nothing more. And this will create a hyperlink to the documentation string of this function called some function. The second enhancement is to refer to some section in the documentation itself, not a doc string, but some section, for example, in the tutorial. Or look the section how to compile Julia or something in the tutorial. Then you write the name that you want to refer to, again in brackets, so we create standard hyperlink, but now the link itself is @ref and then the ID of this section. We will learn later how to tag a section with an ID, but for now you can use this syntax in your doc string. And the last syntax is if you want to refer to a citation, a scientific citation, that you would use your BibTeX citation key, and then again in square brackets, and then @cite command. This will make the citation reference, as we have seen. And as I said, at the moment, you write this in your Julia file, and they won't do anything, but once we compile the docs later, there will be hyperlinks. Let's show this again one more time, just to make it as clear as possible. You see here, this is just normal text, but when I go to the compiled documentation, this is a hyperlink to the paper that I want to cite. Right, so here we go now. Exercise, most important exercise, I would say. Yeah, so you should take a good 20 minutes now and write good documentation strings for, let's say, the 5 to 10 most important functions of the code base that you want to document. And please try to use this very nice advice for documenting these documentation strings, okay? The time here is somewhat arbitrary. Do whatever you can achieve in these 20 or so minutes that we will have open. Sounds good? I hope it sounds good. Stop at 14. And if I'm going faster, you don't understand something, you stop me, all right? All good. And technical questions, we're here to help. Right, very nice. I'm not so curious what my people
already working on the server. What are you rendering it with? Are you just rendering the markdown? Ah, you have to read. When I say render, I mean that we will compile it and make those. Yeah. Oh, you have this already. I'm sure I have. Yes. But you have to compile it. No problem. Okay. Yes. No, that's the same. That's all you have to do. This will become hyperlinks at the later section of the tutorial where we will compile the documentation by HTML. So that's all you have to do for now. Just make sure you have this special markdown section in your documentation. What are you doing? Very good. Let me bring one of them to show first notes already.
Yeah, I'm using Sway the way that you're yeah, I'm glad to know I mean, also now it can feel like as I get more like responsibilities and I sometimes I'm like I cannot like it's not everywhere now, but I mean it's very bad. So I like okay, I have to start reducing because like it's let's say yeah. Yeah, it's I was like, I can work with it. So the window basically we don't really get packages integrated. So there's like some easy down and then but it doesn't work as well. One moment. And I was like, oh, how hard to work to go you know, I made these compromises now. Yeah, I run into it. I run into it.
For me, the third
Actually,
yeah,
I would say, like I told you,
that's my advice.
so I think if you want to for your main work, I'm not sure I would. So but actually many things are so for example, let me show you how complicated it is. This is all you yeah, so you can like
Yeah, well, they're not huge. Yes, you can do it this way as well. Personally, I would have all the arguments to be like, I would say great because, I mean, what does implement great cover? You have to also use names somehow for the description of the function. Like, how does the function use them? Ah, okay. Also, yeah. Right, and then from other documents.
probably fine.
Yeah, I would just copy this entire thing and just put it there so there is also the type. Because your types are not trivial. At least I was in my eyes confused.
I was like, I think for me, this
Or two or three. And I like this is, yeah, exactly. That's the difference. Now you can just later if it works with higher, basically you have this ready for you automatically. So you just use this as to remember your syntax. So you just that's right. It will just or you know whatever some kind of service that you want to use, and then you just kind of get how it is to use it. Once you can get, then you can make them. So for this kind of stuff, then maybe don't change. I wouldn't something about it because it's here for you. Let me show you how I approach it, and you will see it's the same as yours.
Right.
Then I screen the functions of this API. Here I see actually the functionality of I didn't remember the name. Then I use the three items. And then the doctor that's kind of a definition. Yes. Mirrors. Now, if you returns to this, yeah, so this tells you this is what the two functions that you have. So that's how I look at it.
This is what we've done.
Means I don't do it experiencing.
Yeah.
You have something like
Yeah.
not too worried. But what the switching right? And I'm gaining in all using my management skills.
But just so you know, the situation how the and clarify is not global. I like this approach, but they need to have better.
Switching background plan.
This guy is just
Dat is
Houdt alle informatie bij je.
Ja, dat is
Ja. Ja. In die functie. Die functie maakt dan ja, een modeling ODE system that describes the behavior of the behavior and governing functions.
This is fine. I will when I look over you, I will have an arrow on the signature. An arrow return.
Weet je wat ik als je automatic je altijd van links naar rechts.
That would be one way to do it. Or you write it in the description. You are flexible as long as it's we are it's fine. You guys messed me up, right? But this means all noise is so after the break, we have 1 hour and a half. Right. What time is it work?
Okay. Oops. 7.
Yes.
What if the return type is something that's returns into should just be like
Don't take a small state distraction. Just to clarify, we know I will split this documentation to the groups for each of the groups. Yeah.
This is a different one.
Right. Okay. So,
Sure.
yeah. I think if the message is not doesn't matter. If it's just say the return a sticker, it does it matter whether
Ja, maar wat dan?
Okay, and the common break is
Listen up, everyone. Sorry, there is a change in schedule. The coffee break is earlier, but I don't want us to interrupt the flow of the next section because it's also important. So what I state is that break starts now and it will end at 14:40. So our break will stop 5 minutes before the formal break, but this also means you will be first in queue for the coffee. So thumbs up for that. So just remember, free time now, but at 14:40 I resume. Okay, and you can still ask questions, of course. Okay, 14:40 we resume.
That's fine.
So please and some I will use if I want
I'm just going to say that. Yeah, that's true. And usually my recommendation is I know it's not Julia system, but there is no student center for this kind of
so if I have my multiple dispatch This one. Again. And this one. Good question. Yeah. No. So, how does the system distinguish between ref or the two functions? Okay, I see.
Thank you. Very nice presentation. Thanks. You're welcome. Thank you for joining. Normally, just write integrals /
You to put it in a math block.
okay.
If you see the doc string here, sorry, not this one, here, put it at math,
All right.
and then you write LaTeX.
Okay.
But be careful because Julia has, exactly, if you use the LaTeX slash, you have to add the second slash. So the LaTeX slash becomes two slashes because in Julia slash is a special character, so you need to escape it, so to speak. So that's how, okay?
Okay. Thank
And
you.
then normal LaTeX syntax, all LaTeX syntax works fine, in my experience at least.
Thank you.
You're welcome. Oof.
I think I remember your name from Julia Music.
Yes.
That's also your MIDI package.
I made the MIDI package,
Yes.
or I maintain the MIDI package.
Okay, so you play drums?
I played drums for a long time now. Yes. Yeah. I haven't played lots in the last year because life got the better end of it. But soon I will be back on playing drums. All the time.
Yes. I'm presenting a talk on a tuning system on Friday.
Oh.
Which I think might fit into the
Of course.
Julia Music.
Interesting. I have it start actually. I want to participate.
Yes.
So is it analyzing? Is it like a signal processing approach?
No, it's more like so. What I wanted to do was actually to study how does a certain melody or a certain chord sound in different tunings.
Oh.
So a equal temperate tuning, grain tuning, just tuning, just intonation tuning, all of these things. So that's what the package does. So
okay.
it can almost take a MIDI file and play it in one of these tunings. I didn't do the whole that part, but it's very close to doing it.
So at the moment the input is a, let's say, wave file?
No, the input is actually a string, or it's actually just a list of pitch tones. So that's why it's very close to just taking the MIDI structure that you have and just extracting.
Yeah. Actually, there is a function that, given the string representation, it gives you the note
Yes,
as a MIDI.
and I use that.
Okay.
I use your number to or string to number function.
Right, string to number, yes.
So,
Yeah. Okay, great. Well, I'm looking forward. I'm always interested in music.
yeah. So right now I'm documenting the fact.
Very good. Fantastic. Very nice. Right. I'll get some water.
Can you do me a favor and count? Yeah.
Estás de verdad
No, start now.
Wait. What time is it stop? 15:30? What time? 4:30. Oh, thank God. Thank God. Okay. Okay, thanks. I just got stressed so much. Okay. We start. Why is people missing? I told them 40. Let's bring them now. Can you please give us out? Documentation workshop is starting. I'm not waiting for anyone.
Ask a small question on your if you use that alt route you showed, and you're referring to a script from another package, does that work?
That works. You have to include it when we build the documentation. I will show you later that for it.
Cool.
Right. Right, let's go. So the previous block was the most important block. This block is the hardest block. So I hope you drank your coffee and everything. Maybe you have a second coffee. Well, be careful for what's coming for you. Great. So now we have, in principle, at least the basics down. And the basics is the summary and the documentation strings. The next part now is the priority number 3, which is the one overarching tutorial for the whole of your software. And for this, we also need to get introduced to the software that we will be using to build the docs, which is Documenter.jl. But before that, documentation. So the overarching tutorial or introductory tutorial or introductory guide, you can call it however you want. But you have to know that this is really a demonstration, not an explanation. It's supposed to tell you how to make a software work, not how the software works, okay? What is a tutorial? In my opinion, it is a concise but typical workflow that utilizes all major aspects of the software. What are the major aspects of a software? I will have here an enumerated list, and then I will go into an actual tutorial or overarching tutorial and go through this list one by one. The tutorial starts with the opening statements, a couple of sentences of what is this tutorial about, what are we expected to learn, what is the typical workflow for using your software or your code base. What are the main inputs that your code base expects or provides? How do you create them in code with actual runnable code? And how do you use them? So you introduce the new, if your software provides some new types, you have to introduce them. If it expects existing data structures, you just create them. What are the typical or the key functions that are provided by the software to use this key input or main input? Showcase a small variety of typical functions. And what are the main outputs of these typical functions, as well as how to use them. So at this point, you attach a typical analysis and or visualization of the main outputs. The next step is that you add a bit more variability. So you go through this loop of input, key function, output analysis. This is a simple loop, let's say. You should go through this a second time with more aspects of your software, if some exist. And of course, you conclude the tutorial with links to the rest of the documentation. Where will you find the API, which are just the doc strings, remember? Where can you learn more? How the software works, other software that are related, etc., etc. Now, absolutely crucial, tutorials and examples showcase runnable code and are run. I will first show you such a tutorial, and then we will discuss how you do this run aspect. Right, so this is the latest tutorial I've written so far, and I really tried to base this almost exactly on these 6 bullet points I just presented. It's a tutorial for a software called Documenter.jl. It starts with some opening sentences that say, this is the software. It will walk you through the main functionality. What is the main functionality? It is, given a dynamical system instance, find all its attractors and their basins of attraction. Then continue these attractors and their stability properties across a parameter value. Now, this might sound like gibberish to you, which is normal, but this is what I mean, that the software prefaces what is the main workflow. There is a short version of the tutorial here that is copy-pastable, that you can just copy it and run it, and it has some comments. We skip that for now, and we start with the main input of this software, that is a dynamical system. So what this piece of code over here does, it simply creates this main input. Then we go to the first or the second main input, which is something called finding attractors. That what it does, it finds attractors. That's what it says here. So we have this key main input that is listed in the tutorial, and this is how you create this key input. So now we have finished with the first bullet point of this tutorial. Let me also show the bullet point, because of course you cannot possibly remember everything. So we finished this number 1 now. And what's number 2? Apologies. We finished number 2, of course, which is the main inputs. What is number 3? Number 3 is the typical or the key functions. So the tutorial proceeds and shows you the first key function over here that you don't have to understand unless you are interested in this particular software. A second key function. And then it discusses what is the output of this function. The tutorial says, you know what? The output is actually just a standard Julia dictionary. So this already gives you a lot of information how to use it. And then it visualizes this output. So this is what I mean by number 3. What is the typical, number 4, what is the typical analysis of such an output? The tutorial proceeds with more typical analysis of such output here. So this is more typical analysis of this output. Then the tutorial has some input variability. It shows you, well, this input we have created so far, there are different versions of this input. Here, how you make a second type of input. It continues on, and then at this point, we now are in number 5. Number 5 is more variability in the sense that now we go into a second stage of key inputs. So this software provides 2 main functionalities. The first was discussed up to this point over here. And now I discuss the second key functionality following exactly the same loop. I go through and I say, what are the key inputs? For this particular example, I am lucky because it turns out the key input is actually the output of the previous step. So I don't have to discuss it again. Then what is the key function that you call? That's the key function. It's just called global continuation. And then what is the key output? Here I say, actually the output is just 2 vectors. So once again, this already gives the user information. How do you use this output? And of course, there is the complementary, customary visualization of the input output that I will let it play because I think it looks cool. That's the only reason. That says, okay, like given this output, that's the typical visualization. And if I scroll down more in the tutorial, it will show you also a typical analysis workflow of this output that we don't have to care about now. So it's fine. So that's what, in my opinion, makes a great tutorial. It's really amazing to me because this is like literally one slide that it took me like 5 minutes to go through. And this is really the most important knowledge I could distill upon you. And it's also what is the hardest thing to achieve, because to write such a tutorial, it will take you weeks, but don't be discouraged, right? Right. What I have here is more packages that, in my opinion, have great tutorials. I'm completely unbiased because half of these packages I have written, right? No, but the point is I really want to be able to present something that I personally can vouch for. So that's why most are my stuff, right? Great. And this is a nice tip and trick that I actually saw from the package called modelingtoolkit.jl, where at the start of the tutorial, if I go now to the tutorial, there's this nice copy-pastable version of the entire tutorial. If you can manage to make it so small, it's not really always easy, but you can just copy it and get started immediately. Right. And it's really, this slide is really all the knowledge I can give for what makes a good tutorial. Of course, we will interact while you write it, but this is the slide you will be referring to when you're writing your own tutorial. Great. So when we compile our tutorial, we are using these two packages, Documenter.jl and Literate.jl. Documenter is a popular package, in my understanding, the most popular for creating documentation for Julia packages. Its main features is that first, it provides these enhancements to the Markdown syntax. Some we have already seen, for example, this @ref special syntax. It executes Julia code blocks and interlaces them with their output. Likely maybe this was not clear in this tutorial that I went through, but for example, here, you see this is a Julia code snippet, and at the end, it's its output. So if I have copy-pasted this into my REPL or my Julia environment and I run it, this is what I would get. So Documenter automates this for me. It takes the Julia script or code snippet and it provides the output. Great. And it has some a lot more other goodies that at the moment we won't discuss in much more detail. Literate is a companion, I would say, to Documenter. And its job is to take a runnable Julia script and convert it or translate it into, for example, a Documenter Markdown file. This is the input Documenter expects, a Markdown file, or other formats like Jupyter notebooks. And in my opinion, the best approach for creating the main tutorial and all examples of your documentation is the following. You actually compose a standard Julia file, .jl, that is a script that has comments. And then you give the script to Literate, and Literate makes it a Markdown file for Documenter, and then Documenter takes this and makes the actual HTML compiled documentation. What is cool about this process is that once you set it up properly, you only have to write a Julia file that you could reuse in your test suite. You can send it to a colleague of yours, and they can just run it without needing Documenter or Literate or anything. I have a plugin here. There is tomorrow a talk again for literate programming called Natural Science Computational Modeling and Literate Programming at 2:20 in session 3.2 that would be related or would be interesting for someone interested in literate programming. Great. So this is these amazing packages that we are blessed with and we can use. How do they work? Well, we mentioned in the first part that where we compose documentation strings. Can you see my mouse? No, right? Oh man, sorry. Right, yeah. So we have seen these syntaxes that enhance your documentation strings. Now this, the key input or the main input to Documenter, the Julia package, is a Markdown file. So imagine that this square is just a Markdown file in your computer. You write standard Markdown and you can enhance it with syntax that Documenter allows. For example, this is a section in your documentation because it starts with a hashtag. And you see you can create a link to this section and label it with a particular ID that I call tag. So some section @ref tag, it will be a hyperlink to this section in your docs, tag section. There is the other syntax from Documenter that is @index, and this is it. You don't put anything inside, and it will simply list all the documentation strings that have been expanded in your documentation and hyperlink all of them. It's like a short table of contents, for example, but only for documentation strings. Another section over here, and this is, I would say, perhaps the most important block of Documenter, the @docs block. This block, you simply write in the documentation strings or the function names from which you want to extract the documentation strings into the docs. So to show this, just to make sure you guys understand what I mean by that, is This is a documentation string of this type called tractor mapper. And the way I actually added this here, I didn't write this. I just wrote literally. I wrote @docs @tractor mapper and then closed backticks. And Documenter automatically extracted the actual documentation string. Now, this is also where the @ref syntax comes into play. If you reference a function with backticks, Documenter will link you to the documentation string of this function. So Documenter understands that this is a function and finds its doc string. The second most important input or good thing from Documenter is the example blocks. An example block is something that I write in Markdown, but it is actual Julia code that Documenter will run and then will interlace it with its output, as I showed in the actual build documentation. The output of the code block is just its last statement, as is typical in Julia programming. And you see this example block can have a declaration, a name. And if the name of the block is the same, this means that the blocks run in the same environment. So in this block, I use the variables I defined in a previous block. If you're plotting, as I do with Macchie, returning the figure makes the figure exist in the documentation. This is super duper important, guys. I cannot stress this enough. There was this nice figure over here that I showed in the docs. I didn't link this figure. I didn't save it somewhere and then stored it. The code made this figure. This is what I mean when I say example must be run, not written. I'm not saving this figure and then hyperlinking it, as has been done for the last 6 decades of software development. I am creating this figure. This is the only way you can guarantee that what is actually shown here is what the actual code generates. There is no other way in my knowledge, so let's follow this amazing principle. Yes?
Is it possible to do the running also for the README file?
The README file becomes a doc string. You could include it formally. So I can create here, sorry, not here, of course, here. Here I can write a piece of code that finds the location of your README file and includes it as a file, but the README is a markdown file though, so I'm not sure how easy that would be. It sounds difficult to do, I don't know. Maybe we can discuss this in the break to not take too much time. We need the experts, I don't know about this. Right, great. So now, I presented this. This is a markdown file, remember, .md. But what I'm telling you is that you shouldn't write a markdown file. Instead, you should make, so instead of making a markdown file, which is what you see here on the left, I say you should make a Julia file. And then you will use literate to make it a markdown file. Now in the Julia file, comments will become markdown, while code blocks will become @example Documenter blocks that Documenter will take. This might be a bit difficult to comprehend. I know it's a bit messy, or it's not messy, but it's a bit advanced. But in essence, I believe this is something simple. You don't write the markdown document, you actually write a Julia document that will be translated to markdown. Is this clear? If not, just ask, right? So the way this works is that you use the literate package and you just call a single function called markdown from this package. You give this package your Julia file, and you give it an output path for where to save the markdown version of this file. Okay? Right. So just to make this as clear as humanly possible, can I even make this as clear? Yes, of course. Right. So source. No, docs. Source tutorial. So my tutorial file is an actual Julia file. It's not a markdown file. Some other pages of my documentation are markdown files. So this is a markdown file, which will also become a page of my documentation. But for cases where you want runnable examples, I think the literate approach is better. Great. Tip and trick before we go into the exercise: Word is gold. Okay, Word is gold. This means two things. The first thing is really about conciseness. That is, everything you say in the docs should be, you should weight in gold, as it costs you a lot of money to put there, for example. Don't make the tutorial longer than necessary. Don't say things that are not as important. Really have the tutorial focused, concise, and a really golden piece of information. Also, don't include unnecessary or external information. In my opinion, the documentation is about the software itself. You shouldn't say in the documentation how you use a text editor, because this documentation is about this particular software, not text editors. Information for how to use a text editor can go in a course that you are giving, for example, for students. Now, the second aspect of this word is gold is the quality aspect, that you, in my opinion, should be careful to write good docs and not sloppy docs, because my experience or my line of thinking is that if you have a low quality page in your documentation, this can be actually worse than not having this page at all in the first place. The reason is because, for example, if it is misleading, then you clearly have done more harm than good. If it is confusing, again, you have done more harm than good. And this can lead to decreased trust overall in your software. In my opinion, it is better for something to not exist than to not be good. So that's also why in this several layers depth of exposition approach, there is a priority. You have finite time, it's better to put it and make the things that are important good than to try and make everything not good. That is my take, at least. Right, so here we are, the hardest exercise block of this workshop. Write your own tutorial. So your goal now is to really make this whole thing. No, not the whole thing, I'm of course trolling you, is to lay out the outline of your tutorial. Start thinking, what are my main inputs? What are my key functions? Let me go to the best slide ever of this workshop. Let's go back here, not here. Oh man, animation, so many. Right, okay, finally. What are the key inputs? Key functions that use the inputs, key outputs of the key functions, key workflow or analysis of the key outputs. So a loop composed of 4 steps: input, main function, output of main function, and typical analysis of main output. Make an outline of these 4 things, and if you have time, also make an outline of doing these 4 things again, but for more variety in your software. Different key inputs, different processing functions, and so on and so forth. Make it as a standard Julia file. I will show this Julia file again. Standard, oh no, right. Sorry. Standard Julia file, where comments will be made into Markdown in the future, and actual runnable code will be made into code that has been run and interlaced with its output in the docs. Don't worry about how this happens. It is the next block on compiling the documentation. For now, just focus on making such a nice tutorial.jl file. Sounds good? One moment, and I will answer your question. Yes, please.
Where we should keep the tutorial.jl file for now?
For now, it doesn't matter because moving a file is a 3-second process, so you can move it later. I will show you in the next block. I will show you where you have to put it. There is a specific location. For now, it doesn't matter. It has to be in the docs folder. Okay, there is a very large time allocated for this block because it is a very hard block, but it is actually very fruitful for you to invest the time and do it. And there are a lot of people here that will guide you and help you. Okay, let's go. Let's do this. You can do this. I believe in you, all of you. Right. Okay, I'll take let's move from an exercise session, so you can work on the exercise if you want. Good. of running the README file, right?
Yes, I would like to do something similar.
Yeah, you can use literate to generate the README, which literate itself does. If you look at the so then you can at least run the function there. It's a bit tricky, I guess, with images because you would have to somehow commit them while you run the job and so on. But you can at least verify the basics.
So I have something set up in German, and so I'm trying right now to figure out. Now let's say I write a literate file. Can I put something into the little JL that kind of runs the literate? Okay, then I don't understand how to do it, and I don't find it in the.
Contributions welcome.
Yeah. Okay. Okay. Well, why don't you tell me how to do it, and then I can.
Yeah. I mean, so there are these. In your case, you want to generate
Okay, so I would go into HTML, and I would actually put it here. I see. I was kind of expecting to put like so now that the plugins is selling it.
Oh.
Okay, yeah.
What?
Cool. Then I will type it, and then maybe I'll make it far.
I mean, you can also do some of that.
Yeah.
I mean, I got this thing, but it doesn't actually get any power. Sure, if there is another one, I didn't see it.
It's hidden, that's why.
Oh.
Also maybe some feedback if you want it. I was looking at this in article also, and then I was looking at
Yeah, it works. Thanks. Perfect. You saved me just in time.
and so I was looking at this, and the first lines look like so scary. I was like, do I have to
Yes.
like write all of this? So I actually looked at this and I was like, I'm gonna do this and fill it in. But now I just looked at it again. I was like, actually most people don't understand the ND hash, especially
It's a showcase.
Yeah. I also now that I looked at it again, I see why you do it. So you have like the demo book and the markdown separate. I was just when I looked at this, I was super scared completely and basically closed it again.
You can have a but this I think generates. I don't remember it.
Yeah. No, I think
But apparently, I guess you can somehow make a slideshow with this.
Yeah, I think that's the slideshow to show.
Yeah. So maybe this sounds just the people that I would have.
Yeah, all of these.
Just to understand, like, so you're proposing with
So maybe
the thing you do is you don't have the
basic example. It's just like copy paste will run it.
No, but this is always not the same. So my question is, this takes this file, right? And then it makes a markdown file like where? So it's in this directory.
You don't see it there because it's not there because it's built only when you build the docs.
Okay,
And I don't commit the docs in this in the main.
But you basically don't commit them.
No,
Okay.
I do not commit them.
Okay.
You also won't commit them in our workflow.
Yeah, of course, but also why not have like a reading log here or something? Because it's not like in a build directory like the intermediate files for the.
So what happens in reality is that if you click here, the name, there is a special branch called GH pages, and this is the branch that actually contains the directory.
Yeah.
And you see here the make file doesn't even exist. But if you go to trackers, you will see this is where the actual.
Yeah.
Okay.
The GL file from a
Yeah. First, suppose you have these slides available.
Yes,
I would love to.
I would love for you to have them, both the description of titles and
Okay,
find them.
I'll find them there.
No, this is the old thing.
So the end is that's it. That's a cover criteria.
Oh, wait, are you sure? Wait, that's the problem, because I thought I updated it yesterday. Okay, I will update it now, it's fine, we have internet, so I. Yeah.
So you want to commit to some. Yeah. But this don't generate well what JuliaCon do not.
Ah, so stupid. Yes, of course.
And does this, is this a valid input for the module?
One moment, one moment. Right.
Could you guys try again with the link? I was giving the link to a particular GitHub commit instead of the main.
So you would launch Markdown from the repo.
Okay, here's the packages that you need to make it work. This is a normal standard for the package. You load the package.
So this, and then you will go, like, for example, here, if I want the output file, I want it to show, like, here it's not on, so just leave it. And then for separating it, you use text, so that I don't want this one to be small.
You can also just use comment without any text, and it will still separate the code into two.
And do I have to know? I mean, yeah, so I have to download it.
Yes. I will explain this later. Don't worry about the compiler. Next. Just write what you want to write, and then we cross our fingers.
Let's see about that. Sorry. Sixteen 30. Ooh, perfect. We have so much time.
let's say here I import my package, and I do something, and now I want to do it again in the Apex, and I have to restart a new code, I have to import it again because these are separate kind of. So now you told me that you can do this in one. Okay, so then if I can do this, then why would I still use this? Because this is then basically a script, even though I don't use any.
It's source file ending in .mp or in .jl.
Well, I guess it's empty file right now.
So you cannot actually use it in Julia if it's a .mp. You cannot run it.
Well, but these, for example, these plots are like generated by Documenter. Yeah.
That's true, but if you wanted to do this on your laptop,
I want to run.
Yes, if you want to run, or your friend, or your colleague, or whatever.
I see.
Okay, so the why you recommend this is really like an executable script that is
Exactly, that's the whole point.
okay. One more question, maybe you're going to help with this. So that you have like a tutorial section and it itself object.
Like, how do I?
Like, when do you
Conceptually or technically? I don't. For me, examples like this are more specific or more advanced functionality. It's also referenced in slide 10. It's the slide that introduces the layers of the system. So if you scroll up. Yes.
So I did it using the specific labels and just find your country of mostly similarly sized states. So you don't have like this tiny capitalizations or whatever. And I Yeah, it's that long. Yeah, if you look at all the
Das wäre natürlich schon so.
Yes. So here we have in the Documenter.jl world, this is first the beginning and the and then the actual code. And also these also turn to a code.
This becomes a code snippet and its output is shown up there after the code base. Sorry, I didn't understand the question.
There's also this is like one code snippet, and these return a visual code.
That's not the key difference. The key difference is that this will be run and executed document output will be that. The above is just a comment. It's markdown, it's commented out. You see, this is markdown. That's Julia and markdown. Because I don't want to run this actually. I just want to be presented as code. This is comment, so it won't be, sorry. This is comment in the reader. So when it becomes a markdown, that's Julia.
Yeah.
This is the markdown syntax for writing a code, but it won't be executed. No, it's just markdown. The actual code that you could actually run in this Julia file would also be run. I do this way because I don't want this small version to be run as well, because it's the same as the code we also why run it from.
Yeah. Okay.
Yeah.
So that's understood as what was the reason that you put one in the token? Yeah, and it doesn't want the other. Yeah, so I understand that some of it is executed, some of it is just kind of printed. Why? Well, yeah, for example,
It's confusing.
I think actually literature will not.
I managed to agree to go from the
So why do we get
so how do I use document and now let's see I don't see it.
Yeah, so I think that's the next section.
Okay.
But yeah, basically, so there are also there's a markdown file, and that's the typical input to document.
Okay.
So yeah, so that's that's the file document. So
Okay.
it's markdown and then HTML.
Okay.
So I think that's the next series.
Very much.
So
So I think, so what I'm planning to do is, you know, we can go into the process, we can create a project with and then we can run Literate and taking testing. So my understanding is that Literate will not run the Documenter will basically. So I think now we'll just take this and create a master file that will create the tutorial and put into the pages, which is in particular
It's sketchy.
So with respect to our concern towards I heard that the higher credits just always are cash flow zero and no that another thing I just noticed, I was looking in the way you kind of generate the recommendation and effective videos, and I saw that actually you do a very distinct thing, you download the building script.
This is very, let's not this is so that the documentation is personal, because I like
You can't just put this file in the repository.
it's actually really difficult.
Wow, okay.
The document actually is complained to this guy over there. Why is it so hard to finish?
And now this thing, I think if we run.
What's your name?
So this is not executed. Meanwhile, I think the solution is to it that
If you are satisfied with the
program, Not the I think getting Documenter is pretty good. Otherwise, I also then asked for the like now we
Right, okay.
and so yeah, you basically have to put
Well, where is the tutorial?
So this is we are just so this is the main wrapper. Things are so I guess if you want to do a document directory. You also have something that ain't for example, if you want to plug something, but you don't want to plug it, you can say you have another method. So for example, then in this project we have a VR thing.
Yeah, but that's
Great idea. We'll go to van Joop.
Dat zijn structurele dingen, functionele dingen. Maar in praktijk is die gedefinieerd zijn. In praktijk voor de tutorial dat die zelf functionaliteit moet schrijven.
Oh, let's see. So,
ja, ik wil aanhalen.
yes, so maybe the only thing is because it's used to the directory.
Dat is ook een functionaliteit.
So we don't have it.
Maar eigenlijk is
So we don't have it directory right now. I think if we don't have it, I think we can do using a vector.
I can go.
En dat is wat even staat gedaan.
Maar dat is echt
Because in my
heb je nog een bestaande functie hier veranderd gemaakt. Zeg gewoon, een van de meest basismakkelijke concentratie van grondstoffen in landindelings bestand. Dus je kunt dat gebruiken als een functional module. Dan heb je ook een parameter gegeven dat je gebruikt. Die concentratie, omdat dat
yeah, but for example, the main thing is that you don't see newcomers in your
dan sturen we bijvoorbeeld zo'n vector aan die hydraulica, en dan geef ik aan alle type en ook denk van alles. En die constant carbon geeft aan alles. En dan heb je nog wat dingen speciaal.
Here in the doc directory of vectors, and I noticed we don't actually have the vectors as a system. So how is the language like run using the vectors?
Eigenlijk vooral niet een heel gedefinieerd.
Okay, that's okay.
I'm not talking more than I have.
Okay, then I'll wait for you.
Dat is heel klein naar functie,
Maar hoe zag je ja, het zou wel een diep kunnen hebben.
Oh, wel, ja. Dus ik zou geen laatste dit ook veel doen. Het is gewoon heel veel diep.
Hier heb ik al.
Oh ja.
Right. Okay. Hello. Right. So we go to the next block. Don't worry if you haven't finished, because all following blocks are in parallel working with your tutorial. So if you want to work more on your tutorials, you can do this while working on the follow-up exercises. So now we go to the part where our work has finally, or will finally bear fruit, fingers crossed, which is, given this nice text file that you created, we compile it into a nice HTML. So the workflow for using this Documenter is that you have your tutorials that are Julia files, you translate them from Literate, and it is one of the inputs to Documenter. There are a couple more inputs, which will be other documentation pages that will be written in Markdown. They don't have to be Julia because they don't execute code. Also, the list of pages that your documentation is comprised of, which is also the sidebar of the documentation, and other plugins. So you put all of this into Documenter and you compile it either into HTML or into PDF via LaTeX using the make docs command, which is really what we are supposed to learn now. Now, to do this, you have to follow a particular folder layout and have a particular file. The folder layout is as you can see here on the left. Now, if your code base happens to be a Julia package as well, then you will have these folders already. You don't have to, because you can document the code base without it being a Julia package, but typically it will also be the case. Now, the folders and the files we care about is the ones that you see here, that you don't see, I'm sorry, now that you see, which is a docs folder that is at the highest level. Inside the docs folder, there is a make.jl file and a project.toml file. And there is a subfolder called source that has, for this tutorial, just 3 files. 2 files are Markdown, and 1 file is the tutorial that we just wrote as a Julia script. Now, the important file here is this project.toml that are dependencies that you need to build your documentation. These are, in general, arbitrary and completely independent on your formal package dependencies if your code base is also a Julia package. So these can be anything that you need to run the documentation. So anything that you use in your tutorial, for example, any package. The other key file here is this make.jl, which is a Julia file that uses Documenter and creates your docs. Now, I realize now that there is something missing in this file because it is created in the deployment. But as you can see, actually nowhere in this file I'm activating this project.toml. So you have to fix that. I'm sorry about that. Here in this start, there should be using pkg, the Julia package manager, and then pkg.activate at dir, dir name at dir, so that it activates this project so that it can find all these packages. Of course, the dependencies for building your docs will almost certainly have Documenter and Literate as dependencies, because guess what, you're using them. Then there is whatever other package you use. Now, this line over here translates or converts your tutorial from a Julia file to the Markdown file that Documenter expects. Here, we define, or we tell Documenter which pages we want our documentation to be composed of. And there are 3 pages. The first page is called index. This is a mandatory page. It is mandatory that this page is called index. You cannot change its name. It's mandated from the HTML framework. Then, Then there is the tutorial page. Notice how now the tutorial is .md. It's not .jl anymore because we have converted this to a markdown file via Literate. And finally, there is the API page that you haven't written yet, but you will write in a moment, don't worry. Then we simply call the make docs function and we give it keyword arguments. The pages, modules are all the modules from which we want to extract documentation strings. And Documenter will only make sure to use doc strings from these modules. So if you're referring to an external package, for example, you have to put it in there. And this function has many keywords as well, but that's it. And that's really all there is to it. Now, this is really amazing in my opinion, because in 5 lines of code, you have a nice HTML documentation with crosslinks and run Julia code. It's really amazing. Don't be discouraged if this doesn't work immediately, okay? Just be a bit flexible. I can promise you that this is really easy once you get the hang of it and you understand where things can go wrong and why. So don't be discouraged if the very first time you run this, it doesn't work. Right. A plugin for Documenter.jl. There is a question. Sorry. Yes. What?
In this, so there's you have overarching project, and then you have inside docs with another project normal. When should I then add? Should I add the package like using a relative path, or should I just use the normal add?
Which package?
So in this case, would I add my code base to project.toml? Would I do that relatively?
Right.
Or would I do that assuming it's registered
yes.
somewhere?
So I mentioned that there is a package activate command missing here. The reason this is missing is because actually the workflow we are learning will also automate this for you, and you don't actually have to add your package anywhere in this project toml. That's also why I forgot to put this package command here, because I also don't add my own package. I only add everything else besides my own code base. For you that you have to do this, just be patient for the next block, and then you will see how this happens. So for now, just have it installed anywhere you want it. Let's say that it doesn't matter, and I promise everything will work at the end. Right. Documenter.citations.jl is an extension or a plugin package for Documenter that allows you to use the standard bibtex format that we are all very familiar with as scientists and use it to cite literature in our documentation. This is what enables this at-site enhancement of Markdown that I mentioned before. And the way it works is very, very simple. You first install the package Documenter Citations. So if I go back to this project toml, here you will have Documenter, Literate, and also Documenter Citations. And then you first add a .bib file in this directory, again under docs and source in docs, and you add this special block in any of the Markdown files that you give to Documenter. Typically, I have this at the end either of the API, or I make a special page called references. So you just include this special code block, and this automatically will understand all the literature you cite. It will use your bibtex file and make citations for everything. Lastly, you adjust your make.jl file and the make docs command to have this extra two lines, where the only thing they do is they say, use this plugin. This is where the link to the bibliography or references is. And as a keyword, plugins equals bib. You give this in. That's it. It's very simple. So it's really amazing. I barely can believe how easy this is. Don't worry if it doesn't work for you, though. Right. So that's all there is for this block. Now, your goal is to actually build a documentation into an actual HTML pages of documentation. There will only be 3 pages, 2 of which are trivial. The first page will be the index.md file that will only have this context that you see here. So this is an entire .md file that first expands the documentation string of your module, that remember automatically is the README file, if you have a module. If you don't have a module, this is empty, it doesn't exist. And then the reference is the tutorial. That's the only thing in the index page. And the only thing in the API page, which is the api.md file, is an @docs block that expands the documentation strings that you use in your main tutorial. So in your main tutorial, when you present a function, remember this @ref syntax that I showed? You can find it also in the previous slides. This is where it will be listed. And that's it. These are the 2 pages. The 3rd page will be the tutorial. So if I go 1 slide back, 2 slides back, I'm sorry. That's it. This is where you specify these 3 pages, and these 2 pages are just literally 3 lines of markdown syntax each. So I hope it's clear. Don't worry if it's not. We can have as much trial and error as you want. You see, it's crazy that I allocate 30 minutes for this, which is as much as writing the entire tutorial. But you will continue to work on the tutorial, and we go back and forth. Now, because we have only 45 minutes left, I will decrease this time a bit, so that we also cover the building, the deployment of the docs. So let's say 15 minutes for now. So we'll continue at 3. And don't worry if everything doesn't work perfectly. We will help you as much as we can. At 4, we continue at 4, of course, not 3. 3 is in the past. Right. So try to build the docs with whatever tutorial you have created already. Let's see if your HTML compilation or compilation works.
So we manually make this?
See that you're not using the upload function? Do you think there's any reason to avoid the upload method or the function?
What is the question?
So the question is whether you, for example, in this example, might you propose like in the API block, writing individually the functions where you want to write them off
I don't want to be mentioning in this workshop more things that I have to. If you know the orthodox, be my guest, but why mention it? Right. Exactly. Yes. Right.
But then I saw so in the line it's
Copy the news to the code. I don't know where are you now because it's current working directory, but it's to change current working directory to the doc. This activates the sample. Can you just try to repeat that? I kept the main at the end.
This is a bit of a trial and error. Let's say
Zoals dat menu.
By the way, now that we have the projects activated, that's what I mean,
I think we should do it.
later you can even you were spending all day.
Whenever I was president,
Wow. I'm sure, I mean, I never got so far. I had like several, I never I had 3 months every time and then so you really have to have time to do that. So now it's example that it was
okay.
It might be nice to have it on another table because now it's far easier to read. But I don't think it's going to be something that
I'm still not admitting that.
Yeah, but it should be a long
Hi there. Yes. Yes. Well, this is exactly what we discussed in the tutorial. No problem. Did you download the slides? Okay, I'll show you where in the slides. Go up. Yeah, down. Much down. Wait. Click. And then go up 4 times. One more. One more. One more. One more. Oh, wait. Can I click? Oh, you have the old version of the slides. I uploaded a new one. This is the page that you want. So what I discuss here is that you have to write a tutorial that goes through 4 steps. What are the inputs I expect for my software? What are the main functions my software offers to process the inputs? What are the outputs of this processing? And what is a typical analysis of the outputs?
So basically each .jl script you write this in.
Yes.
This is actually what I've been doing, and I wonder if we have maybe better practice.
Yeah, this is how in fact, I do this multiple times in a single tutorial. So I start with the first inputs, outputs, process analysis, and then later in the tutorial, I show variability. For example, your software might have many different inputs that you can update. So then I say, okay, look, for the inputs, you can vary this and that. Or you might have different variability in the processing functions that offer different ways to process inputs. And then you say, oh, look, actually, you can vary this and that. So I just go through these 4 steps again and again. Input, process, main function, output, and analysis of the output. This is how I structure my tutorial.
And then in the README file, you give a general
Yeah,
explanation.
the README file is also there. You should have it 1 paragraph or 2 paragraphs at most for the README.
Another question. So if there is some intermediate output, would you upload the output files to the repo in general, or you rely on the reader to read the output itself and then use it for another stream?
For the software I maintain, I create the output on the spot while running the tutorial. So the tutorial is compiled and the Julia code is run and the output is presented in the documentation. So for me, I never have to save the output. So it depends on how large your output is. If it's too large and you cannot upload, cannot generate it on the spot, then you have to upload it and provide a hyperlink.
But in comparison, this is a less good practice than if you just make it on the spot.
Yes, it will be better if you can make it on the spot because that's the only way you can guarantee that the code you show and its output is actually the code running.
Yeah.
Thanks so much.
You are welcome.
Meestal maakt er gewoon 1 file dynamisch en dan maakt er dus dat ik dan klein op een end en dan include het gewoon als en dan exporteer die. We doen natuurlijk de pakketjes die zijn maar hij is ook en alles nog niet in de import.
Literate can actually.
You can do anything.
I can go to the modified version and it will include so I guess it depends if they already verified them, I could be verified. I think it depends like if it complains about a missing kit.
Yeah, I think we should try to find out if this tutorial package defines your into this. Let's now use the keywords remote but Documenter leaves it automatically. If we remove if you saw my documentation, there is a source button on the line. And this is not Documenter makes it. Because this source button goes into, and now here we might assume Right. Hello, everyone. We have to continue to the next step. I'm sorry. If you haven't made it work, don't lose hope. You will, I promise. Because the next step is combined pretty much with the current step. And this is, given that you have this framework that can make the HTML pages, how do you host them somewhere for free so that others can actually read them? Because expecting people to create the documentation is way too old school for us. We are not in the Fortran decade, so we can just host our documentation online. Let's see how. Right. Amazingly, to host your documentation online, you just add one more line of code to your make.jl, and that's everything pretty much, which is crazy to believe, but true, I promise. So there is this function, again, from Documenter that is called deploy docs. And you give this function your GitHub page or repo. So this is your username, and this is the name of the repository. And what Documenter will do will try to deploy or upload the built HTML pages to this GitHub page, which is really all there is to it from the Julia side. There are a couple of things that you have to do on GitHub as well to make this possible, but they are really not that hard. Of course, you have to have a GitHub account. I hope this is clear for you. Let me go to the right. Great. I hope you have a GitHub account. And now I will show you how this works for my account. I presented the tutorial of this attractors package. How does the deployment process work? So if I go to this make.jl file, well, that's a bad example. Forget that, because I'm using a custom setup for this case. Let's go to Documenter.jl, Documenter.jl. Right, that's a simpler case, I think. So we go to docs and we go to make. And you see here at the end, there will be a call to this deploy docs function over here. Forget the extra keyword arguments. We don't care about them. There's just the repo. The repo is just the Documenter docs. Now, when you assuming that you are familiar with the concept of continuous integration. If not, it is a way for GitHub to run some computation for you for free just because you have a GitHub account. One of the computations that GitHub does for you is this documentation building. So I will show you in a moment how to enable this, but this is how it would look like. So I'm here in this attractors the attractors GitHub page. And you see here, if I click this, there are some things that GitHub has done for me for free. And one of these things is the documentation. And it is composed by several steps. One is installing Julia. One is installing the Julia packages I need for my documentation, like Documenter and everything else. And one is building the documentation. Building the documentation is literally running the make.jl file. I will show you in a moment how, don't worry. And then there is some post-processing that you don't have to care about. How do you enable all of this? Oh, well, it is actually relatively simple. There is a special file that ends in .yaml that GitHub can use for you that contains instructions how to make this documentation build and deploy. So what you have to do is simply copy paste this file. It is linked in the slides. This is the hyperlink to this file. You just copy paste this file as is, and you put it in this folder over here. Whoops. In this. God damn it. I'm sorry about that, guys. Right. You build it in a folder called .github workflows, and then you put there this documentation.yaml file. Here there are other workflows that you don't care about, but this is where it goes. .github/workflows/ the file that you're supposed to copy paste. Right. And that's it. hopefully. So this is really all that the setup is necessary. Once you push your code to GitHub, all of your code, right? Your packets, your docs folder, this special .yaml file, GitHub will automatically understand that, you have a file for me to do some job for you for free. Such a good guy, this GitHub. And it will run this documentation build. Where will you see it? If you go to the main page of your repository that you just pushed to, if you do a pull request, it will be visible in the pull request. If you just push immediately to your main branch, this check mark here will be a yellow dot, and you can press it and then go to this build. But that's really all there is to it. So let's recap the process for building the documentation. You have a GitHub account that hosts your code base. You copy this file .yaml. It's not toml. I will fix it. To your repo, the folder is .github/workflows/ this documentation YAML file. This is the hyperlink to this file. And once you push your code there, remember what GitHub will do is will run this make.jl file and then deploy the docs. Why? Because if you see this file that you're supposed to copy paste, this is the file that you're supposed to copy paste. It has some text that is just how to install Julia. Forget about that. This is the part of the text that you care about. Guys, damn, all this time I've been trolling. Damn. Right, so here we are. So this is the file. You don't care about the starting step, is some standard install Julia stuff. There is one step that is commented out. This is to one of the questions you have. You need to uncomment this step if you are documenting an existing Julia package, which is most likely the case. If you're just documenting something that is not a Julia package and you just want to write some docs and use some functions from another package, uncomment this. But this is what makes the local source code of your package installed from the package manager and Documenter, and everything can discover it. So uncomment this if that's the case. Then there are two steps. One step is that it is going into the docs folder and activates the project.toml there. So this activates your documentation environment, so to speak. The second step is literally calling the how's it called? The make.jl file. So that's it. So GitHub will do this for free for you in some machines, someone who knows where, I don't know. And that's it. So that's really step two. Let's just spend 10 minutes trying to make this deployment possible. This is probably the most error-prone step of this process. But if you get it work once, it is relatively robust and will work for many years. So we continue now on this make.jl file that you have created. Remember to add this deploy docs line at the end. Here. It's really all you have to do. Copy this YAML file into your GitHub repo and push. Let's try to work on this a bit and troubleshoot. Yes? No, you don't have to set up a key because your GitHub account by itself has a key. That's called GitHub token. There are some more stuff here for some special key that I won't mention in the tutorial. You can read it yourself. But you don't have to set up any keys. It just works out of the box. It's really magic. OK, let's get 10 minutes because then we have to start wrapping up. Don't be discouraged if things don't work immediately. I promise they will work sometime. Yes. Pages is a keyword. You're giving it as a positional argument with a semicolon at the start. Here. Yes. You're using the old slides that have updated.
I'm running a bit behind. How can I link to another page that I've made? Yeah, so I would just have a theoretical overview page. Oh yeah, I thought you were done. So I just want to link to the yeah, it's 50%. Yeah.
It is working. It is actually for global Julia. Okay. It does. Yes.
Sorry,
the add so
yeah, it's basically layered.
Yeah, it's really
you have one global version, and then you can have
actually, so what was the heading? Theoretical summary. So if you set the brackets, theoretical summary, and then the rest will actually work.
Oh wait, I have to upload or in the file where I'm linking.
Here, so instead of theoretical,
Yeah.
no,
Oh, I need the same title.
it needs to be like byte by byte identical.
Yeah. Do I need backticks or no?
Not this time.
Okay. So this
Should be somewhere.
Yeah, I changed it to. So that's optional. You should need to save the file. Yeah. I'm just gonna go ahead and do that because I did it twice.
The other option, you can try the other option, the other rep is you can just don't use that rep, just for the theory.
Without any.
Nothing. Yeah, the only thing is you need to make sure that like the link is relatively correct.
Yes.
Which is
Okay. Oh yeah, it's because I wrote a bunch of documents already, but I didn't do them.
That's fine. We can suggest just this error check. You can just add more.
And make that?
It will show the same error.
Oh, okay. I thought I could this is it also does it need to be some
whatever you want to do.
But if you look at the recommendations,
Oh, no.
is that you should run multiple chains. Because if only is too much the same distribution, you're probably quite sure that you're actually invalid.
Did it need some kind of
But if you have a single chain, you might just
So this might be generated. So one is I guess is what actually generated.
and then it's also the algorithms that
You need to so yeah, so George has a thing about the package.
Oh yeah, the weird thing is, when I added it as a dependency precondition, it got stuck on some false dependency. But when I added it as a norm, yeah, I guess I just try. I think it's that one.
Let's try again and see if we can fix that.
and then you just
You can just do dev, right?
Yeah, it's just like I'm in build now.
Oh yeah.
So I should do it.
and then you create all
No, you can just do dev. You may need to restart the repo because it has the old version.
Yeah. Yeah, I did. Oh, okay. Wait, trigger print files.
Yeah. Might now, so.
So maybe you have to. Oh, I didn't.
Activate the docs.
Okay.
Just give a keyword sign name, whatever name you want to give.
Yeah, I'm not sure why.
Go again. And then you have a bit more.
Yeah.
If you
That's all right. I got
how would you do it?
reasonably far.
And then you would probably read some standards that is really amazing.
I looked it up and then was like,
As a standard,
What I can do is silly thing. You can disable pre-compilation.
yeah, how do you do that?
There is an environment variable you can set. That's package package like package will just pre-compile 0 or something like that. So hopefully it just doesn't trigger whatever code it's like. Something gets triggered and then it's fine.
The weird thing is I can just I can run my package because I also have this tutorials thing where it's already pre-compiled and then runs first. No, this is just it's whatever. I'll figure that out and then
You could do it before the use stage.
oh, before anything.
Well,
And basically in there, you should run for shades.
So now I have to restart grep. Learning some dark JuliaCon.
I mean, this is a workaround. The correct solution is to sort out the pre-compilation. But
so because
directly yes.
What? Hey! I didn't care.
which yeah, it's something so it looks like here. Punches above it. So I will not try to
Julia saw my sinful way. Huh.
about what
What do
happens.
you do about it now?
No, if you can do it.
Yeah, well, I don't think you can fix this right now.
That shouldn't work.
Fix this under time.
It's basically fighting everything.
It's weird that it didn't work.
Yeah, thanks for your
I don't want them.
And here's it's doing like the box. So then the thing is that even the yeah, this is something I didn't know about.
This is correct. Here's name should definitely the part of the so it will give you the this one's so the problem is that if you go to here you have refreshing that page. If you go to the web, but I'm not really happy with this. Thinking about you are spending because you want to have this.
Yeah,
free package or something.
Well, at least there ain't no about it. Did you like ever register packages? Register packages. In Julia. Yeah. So that's the work is pretty good, but sometimes I'm also like.
Hi. Hello, everyone. So we have to progress now. I know this was not enough time, but actually we cannot afford to be late with the workshop. We really have to end soon because there is a storm warning. Like I think at around 6 to 7 there will be a heavy, very heavy storm, and at around 5 I guess it will start with a light drizzle or whatever. So if someone is here by bike, they really have to get going. You shouldn't be outside at around 7 o'clock. So I will wrap these things up now. Again, I'm sorry this is not enough time for you to finish everything. Thankfully, you can refer to the slides. So in the workshop now you graduate. You are the best. Very nice. Thank you for joining. I have a couple of slides that talk about principles for maintaining the documentation. I will really go fast. The principles here is that documentation should exist only at one place, in my opinion. Don't spread documentation across READMEs and GitHub wikis and private web pages and GitLab pages. I have seen all of this in practice. It's better if all the docs are just in one singular place. The other thing is that a thing in your documentation should also be defined at only one place. If you explain something, you should do it only at one place and just cross-reference this explanation. Don't copy-paste things around. Nice meme, but we have to carry on. This is what I like to put in the home page, the starting page of the documentation, which is the index.md file that we don't have to discuss because you can see it in the slides. Making a logo is actually a really good idea. I strongly recommend that you do this. It gives your software a face. Something I want to spend a couple of minutes is really the sidebar or the table of contents. Now you see when someone reads your documentation, what they want to do, in my understanding at least, is to really immediately know where the information they need is. Now, one way to do this is with a search bar, but that's actually not always useful. I don't know why, but sometimes searching doesn't work, doesn't give you what you need. So the second best place is this thing here. This is the sidebar. So this is something you can scan within a couple of seconds, and within this couple of seconds, you really should know where the information you want is. This is what I call in the slides the eye horizon. So within the horizon, your eye can see the information should be there. So what this means is that you should take the time and really structure the table of contents so that the information is at correct hierarchies, and also the levels of hierarchy that are the most important are highlighted appropriately. So this is the sidebar of your documentation pretty much. And the last one, I think the last tip and trick, is read it. You should be the most frequent reader of your own documentation, because that's the main way you improve your documentation, by reading it yourself and seeing where it's crap and when it's not crap. That's how I write documentation. Primarily, I read my documentation. I don't write it. And that is really my advice for you. Read it again and again and again, and be very critical of yourselves. I have a couple of questions you can ask yourselves here for the docs. So the concluding slide is really, I'm just showing some packages that I've asked around who can tell me a package that is well documented, and I just put them here, just so you have references for writing your own documentation. And that's the end of the workshop. What I have originally planned is that we have more time to work on the docs. It took much longer than originally planned, which makes perfect sense, actually. So that's the end of the workshop. Remember, storm warning, run for your lives. And okay, so I'm done. Thank you for joining. I'm sure you will write the most beautiful documentation in the universe. I believe in you and I trust you. And Frederick now takes the stage.
Yeah, so I just want to mention that if you're interested in the development of Documenter or related packages itself, we have a monthly community call at the last Tuesday of every month. You can find the time and link in the Julia community calendar on the Julia homepage. So if that's interesting to you, then please join us and make these tools better.
They are already very good, just so you know, but we can make them better. Nice. now.